Hi everyone. Welcome to the Skywork conversation. Previously, these were weekly, and now they're restarting again, and this is really great. So my name is Abdallah, or Abdo for short, and I'm going to be your host for today. I'm a research scientist at CWI in Amsterdam, and I'm also serving on the executive board for KAI Netherlands, which is a local ACM SIGKAI chapter here. And so, of course, thanks to Andrew for making this possible. And I'm happy to support this wonderful series. So I'm going to be doing a few hosting sessions from now until the end of the year. I'd also really like to thank our student volunteers, so Alberta, and assistant to the program chairs, also doing a lot of the work behind the scenes. So thank you so much for this. And we'd also like to thank the National Science Foundation for partially funding this event. So some quick logistics. The first part of this event, as you see, is recorded. And we very much encourage questions from the audience. So throughout, as you're listening to the conversation, please note down your thoughts in the chat or save them so we can have a provocative conversation afterward. And then after the first part of the session, typically around half an hour, we'll have an informal social event that's not recorded. So feel free to stay, and then we'll just discuss on the topic or otherwise. So right now, I'd like to very much welcome Sailin Zhong, who'll talk about her work on human comfort in workplaces, designing interactions with and within built environments and involving work contexts. So just a quick bio, Sailin is a PhD student in informatics at the Human IST Institute at the University of Freiburg in Switzerland. And her research interests lie in the conjunction of the human perception of comfort and interaction design. And she leverages environmental and physiological sensing. So Sailin holds a bachelor's degree from Nanyang Technological University and a master's from the National University of Singapore. She's worked at the Future Cities Laboratory in Singapore, which is affiliated with ETH in Zurich, and MIT Media Lab in the US. So those endeavors have enriched her contribution to interdisciplinary research spanning architecture and human-computer interaction. So again, welcome, Sailin. Very happy to have you here. Yeah, I'd like to kickstart with some questions. Are you ready?
Sure.
Okay, great. So first off, I'd like to kick off with your KAI 2020 work on HeloWare. So could you tell us a little bit about this work, your motivation, and generally summarize it and tell us about your what inspired you to do this work?
It was a work before the COVID, and it was under a bigger branch of like a collaboration with an industrial partner where we develop a environmental sensing device to understand indoor environment quality like temperature, humidity, air quality, also lighting, as well as the sound levels. And for this particular project, we're looking for the indoor environment quality because it's more linearly progressing in the indoor spaces. Also in Switzerland, in general, the indoor air quality is pretty good outside. There's no like hazardous particles or gases. But from indoor environment perspectives, the CO2 level can be a problem because it's normally coming from the human metabolism. So in that case, it's kind of universal across the countries, even though the country can be in a very good indoor environment for the air quality. So this particular work, we are looking for the individual level using Apple Watch app, because we imagine that people may not want to be distracted from like their phones or notifications on their laptop, where the watch itself can give a very subtle notification on the wrist so that they can decide whether to respond to it immediately. So from this project, we make 3 different kind of visualizations to address what can be predicted for such kind of information. So here we have the risk, temporal proximity, as well as the certainty. So it kind of coming from the predictive model that we use for the CO2 predictions in the prior work. So generally, imagine a machine learning model, it has the predicted value, which is kind of like the risk, like how high it's going to be in the CO2 level. And the temporal proximity is like how far away that thing will happen in the time scale. While for certainty, it's the model itself, like how certain is that value that we predicted. So in general, how do we communicate this to the users for them to take actions without seeing a huge dashboard on like what kind of particle is there? So here we're thinking about it kind of like a watch faces, because it kind of like a countdown, like let's say 20 minutes later, we see a high CO2 level and how that will approach us in like 20 minutes. So we kind of imagine that in a watch face. That's why we use this medium to show the visualization like kind of like a countdown manner. If you see the paper, there's a screenshot for that. And then to modify the knob length to indicate the certainty of it.
Okay. And what did you find in the paper? You compare different visualizations?
Yes. So interestingly, normally people are not exactly very sensitive to the risk levels, unless it's like very, very different. For example, 50% compared to 100%, we know it can be very, very different lengths. But if it's a slight changes, maybe they're more sensitive to like how close that thing will happen. If let's say it happens very quickly, then they will take action, let's say opening a window. From our small pilot studies, it's like half of the cases people generally will open the window. So communicating such kind of predictive information will be useful for the user in general. And another point is that we have two types kind of visualization. One is just to show the predicted time and counting down. The other one is more like a spectrum, like how it will change gradually from, let's say, now it's kind of okay, and then go to medium, go to high as a severe. And then in that kind of information could be useful for people so that they can plan out their 20 minutes, like during this period, have impression, oh, it's going to be 15 minutes, I can already do something like that, yeah.
Okay. Yeah, so there's a behavior change element to this as well, ultimately.
Yes.
And did you measure this directly? Did you deploy this with people?
Yes, so it was a smaller scale study for this particular app. We did with 12 participants, and we used manufacture. It's like the fabricated data, because we want to see people's behavior without like in the short time that we cannot like force it to be a high level of CO2 in their natural offices. So we fabricate the information, but those participants, they have another study with the hardware devices, such that they kind of have some trust into this fabricated data. We didn't tell them in advance before we interview them and tell them the truth. So we kind of observe their natural behavior from that.
Interesting. I'd like to move to some related work on, again, also indoor air quality in meetings. And so this is a nice example of, or can be a nice example of the future of work. So could you tell us about this? And also, what was your motivation here?
Mm-hmm. So again, this is the set of experiments that we did before COVID. So in general, in that time, it's meeting room can be quite packed, like, and then the CO2 level can go pretty high. And then in a 1 hour meeting context, people normally make the decision at the end of the meeting, right? So in that case, we're worrying like if that decision is made in the time that actually your indoor environment is bad, then the cognitive condition will be the worst actually. So the decision may not be wise for the whole team. So we're thinking, is there a way to for them to manage their own indoor environment quality in that case, like about CO2 again, and how to notify them without interrupting in the middle of the meeting so that they can focus on their conversation. So we deployed these hardware devices for 5 months in 2 offices. And then for one of the offices where they have the log of their meetings, we extract the 1 hour meetings because we think in general, 1 hour meeting, people normally don't go out and will have a break. Comparably, there are also longer meetings, but we cannot know like what people do in between. So we focus on this uninterrupted meeting time and see how the CO2 level evolve inside the meeting rooms. And then we figure out 7 types of CO2 evolution patterns. So sometimes it can happen quite early, let's say in the first half of the meeting, or even before the meeting is already in a high level. In that case, we could already tell the users at the beginning of the meeting, like before they enter, like first of the person, for example, they enter to the meeting room and they can see this predicted distribution of when they will be interrupted for such kind of risk of CO2 level in their rooms. And then maybe at that time, that person will already decide, oh, I will open the window immediately now before everybody come in. In the contrary, there's also other types like happening in the end, more like slowly going up or sharply going up. So there are different kind of types. So in that case, we would like to see how to communicate with the users inside the meeting rooms about such kind of information. So that's why we did like 2 surveys. One is about before the meeting starts. Let's say we tell them when you were likely to be interrupted for that kind of information. For example, at the beginning or in the first half, there's a high risk, or in the second half, and the level of CO2 that is going to be, and then see what they will do in different social contexts, whether it's external, internal, the weather condition in the winter, because there's a trade-off between you opening window is going to get cold, right? So that's one of the survey. The other one is about medium, like where do we notify people? Do they want like a public device? Do they want like Apple Watch, which we did before, or augmented on the environment? So that they inform the next step of the development of such hardware in the future. Yeah.
I have 2 questions, which maybe they're a bit naive, but like first, do people know that this is a bad thing, to have CO2 levels in general? I mean, is this something people are generally aware of that can affect you? And the second question is there a relationship or direct relationship between, let's say, high CO2 levels and some human factors, like let's say concentration, or does it affect us directly? And if so, like, should more people be knowing about this? Again,
Yes,
naive
so
questions maybe, but
no, that's great. That's great questions for our motivation actually. So the first half, yes, we did some surveys like blinking on hardware to get some like subjective feedback to see how people rate their different dimensions of comfort, including the indoor air quality. And we find that there's like people couldn't really sense the air quality. Let's say the CO2 level is high, it's low, whatever, they will give similar like random scores. So people doesn't have a very good sense of how the things goes when there's no smell of it or it's odorless gases or particles. So in that case, that's why we think in that case, maybe it make more sense for like sensing system to come in rather than relying on human sense to control the system, because it's not as sensitive compared to sensors. And for the second question, this is something that the building science, they have been researching on for a long time, where the CO2 can have, when the elevated level, let's say above 1000, it can have a negative impact on their cognitive functions, can also cause like headache or even health issues if it's exposed for a long time. Yes.
Okay, wow, very, very interesting. Normally we attribute whatever factors to, distractions, I haven't slept well, but this is an additional invisible thing in some way, which may sound obvious to, building scientists, but maybe not for the average person having meetings day in and day out, and not remembering to open the window because it's too cold outside, at least here it is. Okay, interesting. So let me ask you just a follow-up to this. You did this work, you said, before COVID, or it was in 2020?
Yes.
And we're in 2023 now. So if you like, do you think if we ran the same study today, would things be different? Given that I guess many people are much more cautious about, indoor air quality. COVID has made us all very vigilant and alert regarding, what kind of airborne viruses there may be, etc. So how do you see your work happening today versus when you ran it before COVID?
I think one thing I will start with the experimental design perspective, and then suspicions about people's behavior differences. So the first part, I think for the HaloWear, for the Apple Watch app, it won't change so much because it's more on the individual level to understand the predicted CO2 level, or in general, if you want to expand to other kind of parameters, it's very similar from individual level to understand the information from the visualizations. Well, for the meeting room study, maybe we will need to do some changes on the survey questions. For example, during the meeting, when we do an interruption to the users, we have a question asking when you are a speaker or you are a listener, like in which cases you will be the one who want to do these actions in general. So we found that actually when they are a speaker, they are expecting others to do this. But now they're much more common that we do a hybrid meeting, even though people are actually inside the same town. They don't even not like geographically very, very different from each other, but it's just a habit change. In that case, with such kind of notification, making more sense to, let's say, made to the online audience where they can also make interruptions. So that could be an interesting question that we can survey people like equally, not only the present people, to notify such kind of situation. The second part about like people's behavior, as you mentioned, that people are more cautious about their air quality in general because of the COVID, and also CO2 kind of is an indicator of your ventilation. So in that case, people may do more actions, I guess, in general, because they see this not only as like to the cognitive, but also maybe their health conditions or the other people's health condition. I think that's in general for all the studies, yes.
Interesting. Okay, so this brings me to something that's very relevant, I think, for KaiWork conversations. And I see you've done also quite some work on hybrid meetings themselves. And you have a work on binaural audio and hybrid meetings. And I very much want to hear about this. So again, I'll ask you to just give us a summary of the work, what led you to do it, and what were the key findings.
So my work generally kind of evolves with the COVID itself, because we live in environments and also the context of work changed a lot. So in that case, for this particular study, we're looking for acoustic comfort in general. So, but in the time that they transit into the back and forth of like going back to the office or staying at home, so it was kind of like a period that we will have this hybrid meeting kind of concept during that time. And then for acoustic, in that case, especially for foreground audio, where we understand people, is mostly the conversation. But when we are facing the screen compared to we're inside the room, is kind of, we have a different degree of freedom of the sound source. Because imagine in a room, then people can be spread out, and then you kind of like can move your body towards them in a quite a larger scale. Comparably, if you're looking at the screen, then your degree of freedom is kind of like maybe 90 degrees like this, right? So we have also observed that the people who are inside who are collocated, they kind of have to wear masks because of the regulation at that time. But study also found that the mouth movement actually is very important cue for understanding conversations. So combine these two factors together, we have tested in control study to understand one independent variable, which is wearing mask and without masks. And the second one is about the audio format, which is the mono format, which we normally have now. The binaural format, which is some of the people are experiencing, like like experimenting on. And then the other format that we fabricated is called a binaural with head rotation to kind of simulate in the condition in the real meeting room where people, when they listen to somebody, they may rotate their head towards the speaker so that the sound actually come right in front of us rather than from one of our ear in the binaural format. So we tried the three format compared to in total 6 conditions to people to see how they would prefer the sound and how would they understand the conversation.
And what did you find? That's
Yes.
what I'm most interested in.
So in general, the binaural format, no matter whether it's the head rotation or not, it's better than the mono format from the eye tracking data. So we use eye tracking data to understand like how people track the speakers, and the binaural audio can actually get the users to track their attention to the speakers more spontaneously, or like following it through our designed dialogue flow compared to the mono condition. But generally, users, they also have their own strategies. For example, looking at the color of the clothes or the tone of the person. So from like a subjective perspective, when we ask them to write down like what is your strategy, they have kind of mixed feeling towards the sound, the audio kind of thing. So maybe for the head rotation format, even though we'll find it better than even the binaural format on comprehension, but maybe the twist time has to be kind of like better adjusted based on the head rotation, which we didn't track at the moment of the paper. Yes.
Okay, so then in the interest of time, I want to move on to the other questions, just so we can get a bit more richer overview, and then we can discuss some of these. I think this is very interesting, actually. You did some recent work published at UBComp 2023. It's I think it was an adjunct work called AirSpec, a smart glasses platform, which is tailored for research in the built environment. I'd like to hear about this work, and where are you going with this as well?
So this is a project with this is awesome. Device. This is a collaboration with the MIT Media Lab, where we kind of tested an unconventional way of understanding indoor environment, where the sensor channels kind of very similar to this one, where we have the like temperature, humidity, lighting, sound level spectrum, as well as the air quality is. So this one, from the value itself, it would be very similar, but we imagine like now it's moving into the context of like working from anywhere. So people are experiencing much more diverse environments. We cannot expect the devices to be installed in all the places. We cannot guarantee like they have access to them, and it maybe even if it's their own device, they need to connect to the Wi-Fi, or like if it's outdoor, like you want to go to a park, it's just impossible to find some like power sources or things like place to position them even. So we are thinking about moving into wearable. And this is another project that they did for physiological sensing before, but we augment the sensor set to environmental sensing. So also, there's also part of the inspiration from another set of building science research where I experienced before as participants, where they actually, for indoor air quality, they have the ground truth as a tube here, like this, to get the ground truth like about your excel of your particles here. So from this inspiration, we're thinking maybe to position the some of the sensors above your nose, it would be very close to how actually human would experience their environments. So from this prototype, we try to distribute to participants in 3 cities in different kind of geometry regions in Asia, in Europe, as well as the US, so that their climate are kind of different. And also to see their problem when they work from different places, mostly home and office, but people also go to like like libraries or cafeteria, these kind of places, and we see what kind of problem they discovered. This is submitting to Kai. In general, we find that people can use these kind of things to discover some kind of issue that they have suspicions on. For example, there's like user figure out like the VOC level, which is like a harmful gases that is existing in their painted offices or their apartment. People also use it to like understand themselves. For example, when they transit from outdoor to indoor, how they prefer the temperature to be, they can see the values there. So kind of match the environment in a digital way. Like they can kind of imagine how the environment are measured whenever they go to it.
So to me, this sort of enables like some kind of citizen journalism in some way as well, right? It can give us maybe a more objective mapping of the environment, which I think is also quite relevant. Okay, I'm going to jump to the one last project, and then we can conclude the recorded part. So I saw that maybe it's different in scope, but I think it was interesting. So you had a work called Nugitex, which is an affective wearable garment that conveys the embodied experience of plants using device-initiated haptic cues. It's a bit of a mouthful, so I would very much like you to tell us more, and what does it mean to be embodied as a plant?
So this one, actually, I was receiving some questions about what is comfort and who is comfort for. So now, naturally, from the building science perspective, you will naturally come into the human comfort because we are the one there, and then we should be centered or something. But actually, there are other species like your plants or your pets and stuff, or even materials. So this one is kind of like explore what's more, like who's more there. So we look at the plants, and in general, we look at the human-plant interaction. It sometimes use the plants as artifact to do something for human to understand, but we want to do the other way around. Like how do we understand how plants feel? So we kind of position ourselves in the position of the plant. Let's say one day feel dry, they feel hot, they will kind of shrink. So that's why we make a wearable device to simulate how a plant can feel on you. So that's when you get close to a plant with a sensing device, let's say it's dry or too hot, and then it will be actuated with a soft robotic actuator with this garment for you to kind of feel like how you would feel in a plant position.
That's wonderful. Okay, I'd like to ask you, of course, several more questions, especially regarding the plants. But I think for now we can conclude the first part of the session, and then we can take the rest of the questions later. Yeah, thank you, Sailin. And we'll be having a follow-up conversation in the hopefully next month, maybe sooner, perhaps. So yeah, we'll stop the recording now, and you're all welcome to join us for this informal conversation afterward.